Okay, now let's come for something called like a product rule. The derivative of uv, will write it as the derivative of uv is written as u dv by dx plus v dv by du. And this called a derivative. So this dx timing, I'll remove it so that it will be easy for you. And this called like a product rule. U and v are two functions. So what is the derivative of them is what we are trying to learn here. The product rule, what it says, like a u and v are two different functions. Then first you keep u as it is, then take the derivative of v, then plus again afterwards keep v as it is, then differentiate with respect to u. Then you'll get the required thing. So what is the meaning of this? Like, sir, what is the meaning of this? We are not able to understand. Okay, we'll do one thing. Derivative of x square e to power of x, we'll see. X square is one function. E to power of x is one function. Then we'll differentiate dy equal to x square as it is. Derivative of e to power of x. Then e to power of x as it is, derivative of x square. Then this will become x square. Derivative of e to power of x will be e to power of x dx. Derivative of x square will be 2x dx. Or e to power of x you take outside, x square plus 2x. What does it mean? You plot this curve. The slope will vary according to this function. There's a graphical. There's a graphical idea. There's a mathematical tool. Graph you have to interpret like this. In this particular curve, you plot x square ex graph. Then how the slope of that curve will vary according to this function. That's the meaning of that. Still, sir, what is actually product rule? I think the physics part is what still we should analyze here. This okay, mathematical tool, everything okay. So you brought a rule, everything will follow that rule. But what is the meaning of this? Let's take a square plate. Let's take a rectangular plate here. This is u. Let this be v. I'll produce a, what is the area of this? U into v. Let me choose this color. Infinitesimal change in length, I'll bring that, I'll call it as a u, du. Able to find out. Similarly, an infinitesimal change in breadth, I'll bring. Okay, let me take that as dv. I to explain the keeping both the diagrams. This will be a better idea. No. So this is what like a rectangular plate. So what was earlier area? A1. Now area is A2. So what is the area of the plate? A1, you are going to write U into V. If I bring small change in its length and breadth, there'll be corresponding change in area. I want to calculate that infinitesimal change in area. What shall I do? What is du? Can you measure? Not possible. But mathematically, can we expect that infinitesimal change in area per unit change in length and breadth? Yes, this is what I'm trying to do here now. The product rule is what going to help us. Basically, the product rule is what is going to help us here. So we'll do one thing. So what was our area? A is equal to A area. Area was equal to U into V. I'll write it. And let small change in its length be plus or minus delta U. And also the change in breadth be plus or minus delta V. The corresponding change in area, let it be plus or minus delta I. I think everyone will agree. I changed the length by small infinitesimal length du. I changed the breadth by small infinitesimal change by infinitesimal length dv. Or here I'm putting change delta u. So this will become, now we'll expand it, a plus or minus delta u, uv plus or minus u delta v plus or minus v delta u plus or minus delta u plus or minus delta v. Delta u is very small, delta v is small. Product of these two small quantities will be still more smaller, and these two will cancel out. I'll take green color, not these two. These two will cancel out. So will be left over plus or minus delta a plus or minus u delta v plus or minus v delta u. What about other quantities? This will become negligible. Delta u very small, delta v very small, the corresponding change will be still more smaller. Okay, now let delta v tends to 0, delta u tends to 0. Then this will become plus or minus dA equal to plus or minus u dv plus or minus v du. This is the product rule. Getting, I'm using in some application. So many rectangular plates will be there where area will change. How to calculate that elemental change in area? There's a formula. So with respect to what they'll change, with respect to with time or with the temperature, the area of plate will change. How to find out that infinitesimal change in area of the plate? It is the formula. So now how to interpret this? What is dv? What is du? What is dA? And what is u? What is v? U is what? Length. V is what? Breadth. What is dv? Infinitesimal change in length. Infinitesimal change in length, infinitesimal change in breadth, infinitesimal change in area. That's the interpretation. Infinitesimal change in area. Infinitesimal change in breadth. Infinitesimal change in length. Now I'll ask you a question. Can you find out by any other method? No, we have only differentiation. There's a meaning of product rule. In books, you have product rule means derivative of u equal to u dv plus v du. But what is the meaning of that? There's a meaning here. It will come like this. Say physics will always come with a reasoning ability. You have to, you should not accept anything as it is. For everything what happened, we have to analyze. We should relate to the real life example. Rectangular plate is a real, not imaginary. Why is our length breadth changes? Many parameters, due to many parameters, due to change, due to temperature, due to absorption of heat. There are so many things are there due to some stress applied. So there are many factors are there which will affect the change in area of a plate. How to produce that like a infinitesimal change in area of a plate is what we are using this formula. Okay, and there's a method. You can pick up some more. Okay, y equal to some trigonometric equations also being y equal to x cube sine x. So then dy is equal to x cube as it is, derivative of sine x plus sine x it is, derivative of x cube. Then dy equal to derivative of sine x will be cos x. Derivative of x cube, 3x square dx. Okay, that some dx is missing. So therefore dy by dx equal to x cube cos x 3x square sine x. any function you can differentiate here. Again, I'm bringing quotient rule. This is called like a derivative of u by v equal to v du minus u dv by v square. Shall we say that, okay, sir, thank you very much, quotient rule, or it is having any significance? Okay, first we'll learn the how to use mathematically. In the end, we'll focus on what do you mean by this particular thing. Okay, now let's take a one function. Y is equal to x square. Y equal to, we will do one thing. Cos x, I'll take it in this case, no? Cos x by x square. What is the derivative of this? So again, this will be dy is equal to v. V is what? X square, then x square derivative of cos x minus cos x derivative of x square by x square whole square. X square derivative of cos x will be sin x. Derivative of x square will be 2x. And the dx is ordered by x to the power of 4. So this will become dy by dx is equal to minus x square sin x minus 2x cos x by x to the power of 4. Then again, so what do you mean by this? You do one thing, plot this curve. Y of x, you plot a curve. The slope in that curve will vary according to this function. Okay, sir, fine. Like, what is the meaning of this? There's a mathematical way of finding out dy by dx. Then, sir, graphically, I want, okay, plot y as a function of x. There, calculate the slope at various points x corresponding to various values of x. The slope will vary according to this function. There's a graphical thing. Then, still, sir, what is the meaning of this? Are you getting now? What actually mean? So in physics, what happens in the real world, we do have quantities where we do express them as ratios. There'll be some physical quantity, which will be a ratio of two quantities, like suppose an acceleration, which will be force by mass. This is a physical quantity, acceleration. Let me write it here. Acceleration is equal to force by mass. So then here what actually happens? So during that experiment, when you're doing that study of some motion of a body, you'll do some error in measurement of mass. You'll do some error in measurement of force. There'll be some. So then what is the corresponding relative error in acceleration? That is what I can use this formula. It's, if there's a small change in measurement, if the infinitesimal change in mass, if there's infinite change in force, what is the infinitesimal change you are going to measure in acceleration? Is what we are going to find out using quotient rule. This later on we'll go for laws of motion. You're going to understand what do you mean by force, mass, acceleration. And in the errors chapter, you're going to learn what do you mean by that error also. Time being, let me proceed here. So let me write alpha is equal to u by v. This is u and this is v. Let me take log on both sides. So this will become log of u by v. Then this will become log alpha log u minus log v. Then let me differentiate this d alpha. The derivative of log will be d alpha by alpha. Derivative of log x. what do we write? Dy is equal to dy by dx, what you write? 1 by x, or dy what you can write? Dx by x. So derivative of log alpha will be d alpha by alpha. Derivative of log u will be du by u. Derivative of log v will be dv by v. Then this d alpha, let me keep as it is here, alpha. So this will be du by u, dv by v. V du, u dv by uv. What is alpha in turn? What we assumed alpha? Alpha we assumed is something like u by v. U get cancelled, so I'll end up v du by v square. Let's come for this one. The same formula, no? Which I was supposed to do that one. Physics, what is the methodology in the physics is like? What do you mean by that? What it is? Why we should write like this? Why we should think like this? This is what primary questions we have to ask. Otherwise, it will be like a just mere, it's become dry. Just we are practicing some sort of like a equations. What is the use of that? What is the significance of that? When we don't know all those things, no, it become totally dry, and we don't get interest to solve many problems. But now, whenever what is u by v, it is some quantity. U is a one quantity, v is a quantity. The ratio of that will be one quantity. Then if u and v changes, then what is the corresponding change in this ratio is what we can find out now. See, u and v will be variable. Then how to find out the infinitesimal change in the ratio of these two quantities? That's what the formula says. V du minus v du by v square. Mathematically, I'm just showing it how to calculate the dy by dx quotient rule. If y equal to cos x by x square, what is the value of dy by dx? There's a quotient rule. What is the meaning of this is what I'm bringing. Means u is a one function, v is a one function. If there's an infinite change in u and v, then what is the corresponding infinite change in their ratio? So what is u by v? U by v will become ratio. So I think then this, please do look at here. What is alpha? Alpha is a ratio. If u and v changes, correspondingly its ratio also should change. So if there is infinite change in u b du, infinite change in v b dv, then what is the infinite change in alpha in the ratio is what we are trying to express. Okay, this is about the basic, the derivative. Okay, I think there are three ways what happen we can interpret this derivative. One, what do you mean by dy by dx? Slope of tangent drawn in yx graph. That's the one thing. Second one, rate of change of y relative to x. That's the thing. The third example is what I'm giving, the physically. We have brought so many examples is what you have here. Let's take the last one, y equal to what is the derivative of like y equal to 1 by